Hello, and now we're going to be looking at the backwards difference. So we have a very similar question. Use Newton backwards difference formula to construct, interpolating polynomials at degree 1, 2, and 3 for the following data. Our x value is still minus a third, and our data is still the same. So I have brought down the data that we had from above. So we have our third difference over there. And this time, all we need to do here is we need to redefine our s. Because this is the backwards difference formula, our s term is going to be x minus xn, where n is our largest term. So if we're doing P3, our n is going to be, xn is going to be 0. If we're doing just a P1, well, I'll show you how we land up working through it. But we're going to be working from x equals 3. It depends how many pieces of data you're utilizing and how you're going about it. But we are going to be going s equals x minus xn over h. So it's important to note that this is for our backwards, and our forward is s equals x minus x0 over h. So that is the only difference, where instead of looking and using our first term as reference, we're now using our final term as reference. So our next difference is our actual formula. So if we go down, I'm going to write out the interpolating generalized formula. So we have Pn, again this is for backwards difference, Pn of x. This time I'm going to write it in terms of s. So Pn of s is equal to, this time we have our an. So I need a different color. I can use gray for this. So we have our an. I'm going to utilize this as our an. So we have an, which is our final term, plus, and this is going to start to look fairly familiar. This is going to now be an minus 1 multiplied by s plus an minus 2 and that you can see over here, multiplied by s multiplied by s this time plus 1. Let me just keep consistency with above. So multiplied by s, multiplied by s, this time it's going to be plus 1. And that is going to be all over 2 factorial. So again, we have the factorial thing going. And that, I'm going to do one more term, plus an minus 3, multiplied by s plus 1, s plus 2. Let me add in the plus 1, plus 2. And as you can probably assume, it's going to be over 3 factorial. And that is going to continue plus dot dot dot, which is then we're going to eventually have plus n minus n. Now remember, in this case, our a0 was here, and we're counting down. With this case, I'm calling this as our an, and then an minus 1, n minus 2, n minus 3, etc. So I'm going to be putting n minus 1. And that is not going to be our a1 from our previous example. This is a different term, because a1 in our previous example was this term here. Because we're going in a different route. So what actually I should be doing here, just to make sure this is clear, I'm going to modify this slightly. I'm going to use a different letter. So I'm going to use a B just to make sure that it isn't confusing. So B throughout. then an or bn n minus 1. And that term is going to be whatever your final term is there, and that's going to be multiplied by s plus 1, s plus 2, s plus n minus 1. So let's do that. S plus 1 plus 2, s plus n minus 1. And that is also going to be all over n factorial. So this is what we land up with. It is our basic formula, and it's, while in algebraic terms it looks a little bit more complex, when we're going to now do it as the example, it's very similar to the previous formula that we were working with. We're just working backwards. So what is a nice way to do it is, when you're doing forward difference, design a triangle like that. And then when you're doing backwards difference, you're going to be thinking of a triangle going the other way. So that way you're always taking the value on the bottom corner of the triangle. So we want to have our polynomial p of 1 of s. So we know that our s is 5 over 3, so we're going to go p1 of 5 over 3. Our polynomial, we have, let's scroll up so we can see our data. So we land up with 1.101 plus, and then we have our first term, which is 0.7660625 multiplied by s. And in this case, s is our 5.3. So multiplied by 5 over 3, not 5.3. And if we land up working that out, we will get our approximated value. Again, I'm not going to land up working this out, but exactly the same process applies. So I'm going to just write out, because all of this is exactly the same as above, your P3 is going to be equal to your P2 plus, we're going to land up with, and P2 I'm not even going to land up filling in here, it fits in exactly as you would above here. So we will have our 0.09375, so we will have 0.09375 multiplied by s, multiplied by s minus 1 and s minus 2. So s plus 1 and s plus 2. And that would be our P3. Just if you're unsure about P2, I'm going to verbally go over it. Our P2 would be P1 as we have it there, plus we would be utilizing this 0.406375 multiplied by s, multiplied by s plus 1, all over 2 factorial. And this over here, what I've missed here, is the 3 factorial. 3 factorial is 1 times 2 times 3, which is going to be 6. And that is backward difference.